Hello, everyone. Thank you for joining this session where we'll do a short workshop about the future of API management, more specifically, how we here at Sol we revolutionize gateways, developer portals, and GraphQL. So we'll be touching a little bit about these three subjects. Just to present myself, my name is Jona Apelbaum. I'm a field engineer here at Solo. I've been here for 7 months almost, and I'm based in Madrid, Spain. And with me today, I got Krisztian. I'm going to let him present himself.
Yes, hello everyone. My name is Krisztian Fekete. I'm based out of Hungary, and I joined Solo just over a year ago, and I'm also working in the same team as Jona.
Thank you very much. So, what are we going to talk about? We're going to give you a brief introduction. I'm going to talk about gateway solution very quickly, and then we're going to start with a workshop where Krisztian is going to start showing you some cool stuff. And then I'm going to take over and go in more details about the actual developer platform and other things. So, what do we do here at Solo? We essentially we offer a platform that consists of three main components, right? Actually, two. One is the API gateway to manage your node south traffic, which is based on Istio and Envoy. Well, Envoy is part of Istio, and GraphQL is one of these components. Krisztian is going to show you some GraphQL stuff later on. Am I correct, Krisztian? Right? You're going to show some GraphQL.
No, you will show some GraphQL.
Oh yeah, I will show some GraphQL. Sorry, that's also true. No, we will show. Yeah, thank you. Krisztian is going to show more about the Excel access, so we're going to cover that. The other part is the service mesh. So essentially, why do we connect these both things together? You need to protect your node south traffic, things like authentication, authorization, rate limiting, etc. And most importantly, you want to keep that responsibility away from the developers, right? So you want to be able to abstract that away into the API gateway. And once the traffic gets into your cluster, into your network, how do you protect and how do you manage that east-west traffic? This is where our service mesh comes along. Today, we will focus mostly on that first piece. We will focus on that first piece, but the platform is a complete platform that offers these elements. So what is our Glue Gateway? It offers 6 main use cases, with GraphQL being an extra one. One is load balancing and routing. How do I make sure to route traffic to different clusters, things like failover, load balancing, etc. Traffic control. How do I manage things like blue-green deployment, canary deployments, or HTTP redirects, header rewrites, header injections, retries, and so on. Advanced security. How do I integrate my external authentication or OIDC with my environments? So this is where external authentication integration comes in very handy for authentication and authorization. Then threat prevention, access policies, web application firewalls, data loss prevention, rate limiting, and so on. And observability, which is Krisztian's favorite subject, where we also, once you implement the gateway, you will have a very good level of observability of all the traffic that flows to your applications coming from external traffic that flows to applications. What you get out of it? Metrics, access log, and tracing. And then most importantly, when you have multiple clusters, multiple gateways to manage, how do you manage them centrally without the need to manage them all one by one? This is why our Glue platform is also comes in very handy for that multi-cluster gateway management. Even though each cluster may have a gateway separate from each other, the management is completely centralized. So just before we jump into the workshop, how do we base ourselves? We are based on open source Istio. We have our own version of Istio based on open source. What we do with it, we elevate it and we bring extra functionality to the Ingress open source, Istio Ingress, / Envoy, and we add things like developer portal, transformation, DevOps self-service, GraphQL, rate limiting, and so on. Everything you see on that slide, plus much more. Right? So we take away we take as to summarize the API, the Istio ingress, and we make that a full-fledged API gateway. Now, last but not least, because it's an important part, so essentially what we also do is not only do we do the API gateway management, where we integrate with things like GitOps, we help with API versioning, as I mentioned, rate limiting, we integrate multi-tenancy, and so on. We also elevate that, and for both internal and external developers, we can also expose a developer portal, which is something I'm going to show later on, which can serve as an API catalog, API documentation. You can do things like key management, and so on, right? Cool. So enough talking. Now let's see how this looks like in practice, right? So Krisztian is going to start with the first piece of the workshop, and we're then going to continue to my piece, which we're going to switch back to my screen later on. Krisztian, up to you.
All right, thank you, Jona, for the intro. So here we have basically a Kubernetes cluster, actually multiple Kubernetes clusters, and this is a virtual environment where I will be working in throughout this workshop and talk. These are the steps and labs that we will cover. Basically, we will start with exposing the product page front end of the famous Bookinfo Istio demo application. We will expose that through the gateway. Then we will take a look at the actual migration use case, where we will pretend that we have an external service that is our legacy service. Let's say that's an old PHP application running in on-premise data center, and we will migrate that to another version of that application running in a modern service mesh powered by our gateway. Then we will take a look at a few security use cases. We will deploy Keycloak to have some OIDC integration in place, and we will see what kind of advanced scenarios can we cover with the information that we can actually extract from the job tokens of our OIDC provider, Keycloak in this case. So we will manipulate headers. Then we will take a look at more traditional API gateway functionalities like rate limiting and web application firewall. And after that, I will hand it over to Jona to talk about our portal capabilities. So let's start with exposing our component.
Yeah, Krisztian, one thing quickly before you continue, sorry to interrupt. Do we want to quickly show what we're going to deploy? I've just sent a link to the chat if you want to click on it, so we can a quick diagram of how we deploy. Just to have a quick overview, if you don't mind. Yeah. Okay. Cool. Perfect.
Yes. We can take a look at that here. Basically, this client is where we will come into the actual cluster. We have two clusters called Cluster 1 and Cluster 2. These are the workload clusters where the business application is running. We also have a management cluster. This is where the Glue platform itself and our add-ons are running. And we will do various things in this actual infrastructure. We will have a few namespaces, and we have also a workspace concept that is basically a logical boundary around certain functionalities, and this can be a very good way to have real multi-tenancy. We will talk about all these at a later point, but this is just a high-level overview of basically the infrastructure that we'll be working on throughout this presentation. So let's go back to the beginning and expose our application first. For that, we can use a CRD called Virtual Gateway. Basically, all of our offering can be configured through Kubernetes objects. So we have a custom resource definition for gateways, but as you can see, we are just leveraging labels to match existing and other resources in a cluster. In this case, we are matching the gateway that's running in cluster 1, and we will use this virtual gateway abstractions to route traffic into that cluster. All right. The other abstraction that we have here is root table. Root table is another part of our API. Basically, here we can specify that all the requests that are going to this sidecar will be routed into our actual Istio Ingress gateway. This is the main parent root table that we will have. This is very nice to create the parent level routing, and after this, certain developer teams can easily add adjustments. There are things that you want to enforce at a parent level, at a root level, let's say web application firewall capabilities, rate limitings, but there are cases when the actual developer teams might have a better idea about what to enforce and what kind of functionalities to enable. So this is another great use case to use a parent root table and then delegate other responsibilities to developer teams.
If I can add just quick things, so essentially, if you take a look at the way a lot of teams like us may have a gateway team, a platform team that manages the overall access to the platform, right? You have the, as Krisztian just showed, you open up on level 4 what port, what protocol to use. You find the main route table, you delegate that to the actual application team that then decides, just summarizing, how to actually route the traffic to their underlying application, right? So what Krisztian is showing right now is just that main route table that the platform team is doing. And we're going to now, I think, yes, indeed, take a look at what the application team is doing, right?
Yes, exactly. To give you a practical example, now we will create another root table. It's called product page because we are trying to expose product page. And this is actually in the Bookinfo frontend namespace because this is the front end of the application. So here you can see that the other team that is responsible only for Bookinfo and more specifically the Bookinfo frontends are able to add some extra routing on top of the one that's being provided by the parent level root table. So let's deploy this as well and move forward. If we check the actual product page here, that should be exposed quite soon because that's all the configuration that was required. As you can see, Bookinfo is here. It's basically a website with information about books. So nothing really exciting here. Now we will add some TLS configuration to this so that we can secure this exposed front end because this tab is basically just using HTTP. So let's create certificates. After we have the certificates in place, let's create a secret out of these certificates. And after that, we just need to patch our virtual gateway that we did, that we created at the very first step. Specify that we want to have HTTPS redirect enabled. So all the communication going to port 80 will be redirected to port 443. And for the TLS stuff, we will use this secret that I just created. So let's apply this as well. All right. After that, we have that ready. We should be able to actually visit the site through HTTPS. You cannot see this, but this is actually HTTPS. It's a very tiny text on the screen, but this is the HTTPS, but then this is the HTTPS version. Okay. Now that we have this, let's move to the migration use case. What we will do here is that we will create workspaces. Workspaces are the logical boundary that I just mentioned at the very beginning. Let's say you have a platform team. A platform team can draw these actual boundaries, so create the actual workspaces, but it can also empower the actual developer teams to specify and configure these workspaces based on their needs. What we will do now is that we will create a workspace called HTTP bin. As you can see, cluster 1 and the HTTP bin namespace will be part of this workspace. And then workspace settings looks like this. Here, the actual developer teams can specify what they want to import and export, import from other workspaces and export to other workspaces. As you can see in this example, the HTTP team will import the gateways services from the workspace of the gateways, and we are exporting the in-mesh Kubernetes service and all the other resources that has this label called expose and has the value true. All right. Back to the actual migration, we will first expose our external service. We will use httpbin.org. If you know this example, you can go to httpbin.org, and that's basically a demo application to test various status codes and HTTP-specific functionalities. We will pretend that that is our legacy service that we want to migrate to a replica of that service, but that replica will be running in our modern Kubernetes cluster. So first, let's create the external service itself. As you can see, we just specify CRD again to have an item in our inventory for httpbin.org. We are catching all the HTTP and HTTPS requests, and this is our legacy service. If you go to lately, httpbin.org is very slow, but it should load. I just tested this before this session, and while it's really slow, it should work. Let's go back and maybe we can check this one later. But basically, this is the application that we will migrate. Now what we will do is that we will edit our root table that we created initially, and we will make sure that we are forwarding all the incoming requests that are using this /get path to this external service that I just specified. This external service is HTTP itself. It looks like the service is really slow today, but that doesn't really matter because we'll migrate it anyway. So let's create this root table. Basically what it does behind the scene is that all the requests that are coming through our ingress gateway will be routed to this external service. This means that you can have communication between the applications that you have running in the mesh with the external service that you have running on some other location. All right, now that we finished with this, we will, oh yes, I forgot to mention, but we have kubectl get all-httpbin. We have the containerized version of HTTP running in the cluster. It has this in-mesh name, and this is basically a sidecar-injected version of HTTP-bin. The only difference between this and this other one is that our version in the cluster works, but it doesn't really matter. What we will do is now that we will simulate a migration where we will direct 50% of the traffic to the local HTTP-bin service, which is basically this in-mesh pod, and the other 50% to this actual upstream service that's on the internet, but not quite working. So
if you think about it, even if it doesn't work, it's fine because it's a perfect example of you're not going to have a second first in the cluster. So whatever happens, you'll have access to the HTTP bin website, right? So even if because I test on my side, it's something is, I think the HTTP1 is down or something. But it's a perfect example.
Exactly, it's like this for at least 2 weeks now. So, but yeah, it's a realistic example. So to have a certain percentage of traffic routed to another service, we can do something like this. We just adjust our route table to have these weights specified. As you can see, this is the external service, and this is the containerized version of the service that is running in our cluster. Half of the request should go to the upstream one, and the other half should go to the local service. Oh, let's apply this. And then let's try to see the actual service. Okay, so when I click this button, this calls HTTP bin through our gateway. If you take a look at here, we can easily identify that this is the local version with with inspecting two things. The one of them, it's working, so we know that this is the local one. The other thing is that if this would be the cloud version, then we would have some Amazon AWS specific headers here because that upstream version is running on AWS. If I try to refresh this, there's a chance that this other request should go to the upstream one, and I think it should go to the upstream one because it's loading really slowly. I think we might not be able to test the actual successful request arriving to the okay, now we have it. Now we have it. So this is the trace ID I was talking about. You only get this if you are hitting the actual upstream service. It was just slow. If I refresh it again, it disappeared because this is the local version. As you can see, it's also much faster.
So maybe it's worthwhile mentioning there is an option that we're not showing here, which would be useful here. You can actually set retry timeouts. And you can set timeout in the platform. So if the platform would detect that, for example, in this case, the website http://bin.org takes too long, more than whatever, you could automatically forward it to the internal version, for example. We don't show it here, but it would be a perfect example of how this would work, right, Krisztian?
Yes, exactly. We were just not prepared that http://bin was behaving like this again. But
we should have that for the live session, perhaps.
Yes, yeah, because we could easily fall back to our local version. All right, and here you can see the actual way the traffic rolls through the ingress gateway. This is the client. This is us clicking on this button and refreshing this tab. It goes through the ingress gateway, and after this, it will go to either the localized version or the upstream version. All right, let's move forward and delete this external service that we just created. Now we will deploy Keycloak. As you might have already know, Keycloak is our tool to simulate various OIDC functionalities. Basically, the goal of OIDC is to be able to switch between providers and use the tokens created by these providers. And with the help of these tokens, you can easily extract information from the authentication token that you can get. For example, you can get the actual multiple metadata based on the client, and I don't want to spoil anything because all of these labs will do these. But basically, with the help of these tokens and an OIDC compatible backend, you can do lots of powerful things. So let's deploy Keycloak first. Then what we will do after this is that we will create two users with the help of a few comments. User 1 will have an email address like this, user1 at example.com, and user 2 will have a solo.io email address. And what we will see later is that we can easily have multiple authentication and authorization policies based on, for example, the actual email address of the user, which is quite powerful. Okay, Keycloak is deployed now, so let's just populate these variables that we will use in later steps. We will just create a token. We will get this token from Keycloak, and we will use this step to read this token, register our client, and basically create our users. This is not something that's very interesting, but we will use these. All right, now that we created everything, we can move ahead and secure the access to our application.
Did you do the export of the token? I may have missed it, but the last step.
Yes.
Okay.
Yes, everything is fine. All right, so what we will now do is that we will create another secret called OAuth. It will be in the http://bin namespace because we will secure http://bin itself, and we will use this token that we just created. All right, so let's create the secret. And then what we will do is that we will create an X-out policy. With this X-out policy, we will configure the communication to Keycloak. So this is why I needed to populate those environment variables to have access to the actual Keycloak application that's running in the Kubernetes cluster. We specified all the callback paths, client ID that we populated in the previous step, and basically that's it. For that, you need an Excel policy. That's another CRD of ours, and it's a quite nice way to have declarative way of configuring external authentication policies. So, for example, you can easily use Argo CD to roll this out. All right. After this, we need to apply another resource called XOut server. This is basically the external authentication server. It's shipped by our platform. It's basically a Kubernetes deployment in the glue mesh add-ons namespace, and this is what we will use behind the scenes. Now that we have this specified, we will update our root table to use our policy. As I mentioned, we are leveraging the labels highly. So, for example, you can specify that in this root table that we want to enforce this OAuth based policies on various routes, and for that you can just apply labels, and all the routes that has this OAuth true label will be going through our external authentication service. So let's make this change, and if we go to HTTP bin, then we should see that, okay, it's Keycloak. So we cannot just log in. We have to actually provide our credentials. Let's try this with user 1. And if we log in, we will see that we are there. And basically, with this, we just secure the access to the Keycloak itself. All right. Then the next feature that I want to show you is that we have open integration. Basically, with this, we can use open policy agent policies written in Rego. What that means in a practical sense is that, for example, we can specify that only certain users with a certain email address could access our HTTP bin service. To that, we can deploy a config map like this, and basically this config map will only allow access with solo.io email address. As you can see, this is the Rego template that we will enforce. It's in the config map, and the payload in the for the email must end with @solo.io. Let's apply this real quick. We will apply this the module to our as part of the XOut policy that I just created previously. So this is the new part. It's a new module. Its name is allow solo email address, and if that Rego script will return true, then it will give you access to the site. So let's go back to our service and log out. And if I try to log in again, we will see that we will get a denied. If you remember, our user 1 has an email address ending with example.com, but our user 2 is a raw email address, so we can log in right away. Okay. Let's move forward. We can take a quick look at how the flow works behind the scene. We have the client again going through the ingress gateway. After the ingress gateway, we have the external authentication component that will authorize the request by reaching out to Keycloak running in a different cluster, and Keycloak based on the job token can either enable or disable, allow or deny the request. All right, let's move to the advanced use cases with OIDC. Basically, what we'll do here is that we will create new headers from the actual claim. To do that, we have to create a few external endpoints and external service because Keycloak is not part of our service mesh, and we need these to have communication with Keycloak itself. But now that we have that in place, we can create a JOT policy like this. Basically, with the help of this, we can actually extract the email from the.
Hey, Krisztian, just to give you more background about why we need these external endpoints is because the JOT policy actually needs access to OpenID to validate the JOT token and to extract the headers out of it, because it's obviously it's encrypted and signed by Keycloak. So in order for Keycloak to validate that JOT and extract that header they claim to insert into the header, you need that external connection. And because by default, the configuration we have now, we only allow connection within the mesh. You need that external service to allow that connection to that Keycloak URL, right?
Exactly. Thank you for this additional context. So with this JOT policy, what we will do is that we will create an additional header. We will call it x-email, and we will get this actual email address out of the claim. So let's apply this. Let's go back to our application, and if I refresh this, we will see that we have this x-email user2@solo.io. So it's this easy to create an additional header based on the token that you have. Another interesting thing that we will do is that you sometimes need more flexibility, and for that, for those use cases, we have a transformation policy in place. With this, you can basically extract a certain part of, for example, headers. In this case, we will use the email header that we just created, and we will get the part after the @ symbol and use that to create another header called X organization. As you can see, this is the regex to get the last part of the email address, and this is the X email header as the source, and we will create a new header based on the value of that extractor. So let's deploy that, and if we check our service, we should now see a new header.
Takes a few seconds. You may want to refresh again.
Yes.
It's at the bottom.
This is where the new header is, X organization solo.io. All right. Then at the end of my presentation, we will take a quick look at two classic API gateway use cases. One of them is rate limiting. For that, we have to specify a rate limit config. What we'll do is that we will do rate limiting based on this newly created X organization header. This is a use case that might be already familiar to you because, for example, let's say you are exposing your APIs and you want to enforce, for example, you don't want any of your clients' organizations to overload your APIs. You want to specify rate limiting based on the actual organization itself. So we will do exactly that. Let's move to the rate limit server config. That's another add-on in our other Kubernetes cluster. It's in the GNU-mesh add-ons namespace. And what we will do is that we will specify that for the solo.io organization, we only allow 3 requests per unit, and the unit is minute. So we will be only able to have 3 requests per minute. After this rate limit server config is created, we can go back and create a rate limit policy. And that rate limit policy is basically enforce that all the routes that has the rate limited set to true, this is a label again, we are leveraging the labels heavily, will be rate limited. The final new resource that we need here is a rate limit server config. Here basically we just specify that where our rate limited server is, and that's again in the add-ons namespace. After we had this, we just enable, we just update our initial root table with this rate limit policy. And for that, you only need to add this additional label that we just specified earlier. Rate limit is set to true. So that means that all the requests hitting this root table will be rate limited. Now that we apply this, we can go back our another tab and do some requests, send some requests to this endpoint. We can do 1, 2, 3, but on the fourth time we have the page isn't working error, and it's 429, so too many requests because we just hit our limit, specified our policy earlier. All right, let's revert the changes. Delete the resources that we just created, and move to the last part, which is the web application firewall use case. There are lots of things that you can do with our web application firewall. It's based on Mod Security, the open source project. But basically what we will quickly demo here is that you can apply web application firewall policies. It's called WAF policy. It's yet another CRD of ours. And if you remember the famous Log4Shell attack that targeted Java applications, then you know that most of the world was affected by that, and it can be easily mitigated by having web application firewall rules in place. Basically, we can specify rules with this policy. For example, this rule will catch all the requests that has the Log4Shell malicious payload.
Hey, Krisztian, if I may, just to give more context, remember in the days, everybody had to go and urgently update their Java applications, change their Java application, etc. This could have been, the urgency of doing that could have been prevented by implementing a WAF policy like this, right? So to give people more time to upgrade their applications so they're not that in a rush, but we had to rush to update everything. And something like that could have prevented that rush essentially, right?
Exactly. It's very nice to have this kind of control where you can have a centralized security or gateway or platform team that can just enable a web application firewall policy for your parent root table, and that way you can easily roll out mitigations without even touching application code or notifying your developers. So now that we have the WAF policy in place, what we can do is that we can apply this to our root table, and we will do exactly that. As you can see, we have these labels, this label called WAF set to true, and all the roots that will have this label will have this policy in place, so that you cannot inject malicious payloads to endpoints that are behind these rules. We can also try it out. It's a curl request, and basically here, as you can see, this is the famous substring that you can use to trigger the Log4Shell vulnerability. If you send this request, you will see that you have this custom message that you can inject. If you remember at the beginning of the policy, we specified that, but basically the request will be denied. And this is a nice way to mitigate a vulnerability like this. All right, after that, there's nothing much. Basically, we are just cleaning up. So I'd like to thank you for joining this session, and it's Jona's turn to talk about the actual portal capabilities.
I was on mute. Thank you, Krisztian. They were awesome. So let's take a look at the portal capabilities, right? So Glue Platform includes that developer portal. We talked about what that is exactly, right? It's allows you to expose, you develop your portal, your API to that portal, which is then some kind of a catalog of APIs. So the way we're going to do that, we need to first start with API discovery. So essentially, if you take a look at what I'm going to run right now, there's a few things that are important to note. We can use if you got existing Swagger specs for your APIs, So in this case, you add that as an annotation, as a label, better said, to an annotation, sorry, to the actual application deployment, right? And essentially, this is going to tell Glue Platform to go and generate the API doc automatically behind the scene, which we're going to have a look at. Let's have a quick look at the Swagger specs. You may be familiar with this, right? Essentially, you can use your existing Swagger specs, and we're gonna Glue Platform is automatically gonna expose them. So I'm gonna run this. Then I'm setting some extra config, like retry delay, pull attempts, etc., in case something is wrong. So I'm gonna apply this. Essentially, behind the scene, Glue Platform automatically generates an API doc, right? You see, like magic, right? Automatically, it creates an API doc that we're going to later on the developer portal is going to use to expose this, right? Essentially, you could also create the API docs manually. It's more work, but you may have existing API docs. But behind the scene, we don't only create the API docs, we create a virtual destination, we create many things to allow then for a route table that Krisztian explained earlier to point to it. So essentially what I'm going to do is I'm going to create a route table. Essentially, it's very similar to what Krisztian was showing earlier, and it's the product page route table, right? Portal users is set to true, right? Because that's the, I've said it earlier on. So essentially I've said every time a route table has that label, please apply the portal settings, essentially. So essentially what I'm doing here, I'm saying, if I navigate to API/API/bookinfo, forward it to the v1 of products, right? To v1 product. So essentially we hide away the complexity of versioning, etc., of application behind the scenes, and we rewrite that to the actual request in the back of it, which is /v1/product. So I'm going to launch this. Essentially, if I now curl that request, you will see that I can access that like a normal API, right? So /API/bookinfo. I've hidden the complexity of doing /v1, understanding versions and what endpoints into one single request. So Krisztian showed it earlier, but essentially just exposing the API is not enough. You want to secure it. So we're going to apply an external authentication policy. I'm telling you that the authentication policy essentially that every time I apply that route, I'm setting API keys to true. Every time I apply API keys to true, apply that authentication policy. In this case, we're not using Keycloak, we're using API keys. You may be familiar with API keys. You get a key, and this is what you use to access the API. We're going to later on see in the developer portal that developer portal can automatically create these API keys for you. So essentially, I'm configure the API key settings. I'm going to also configure the Excel authentication server to kind of take these settings and apply that to the authentication. So if I now try to access the API without the API key, obviously I have an authentication error that says API key is missing or invalid in this case. So let's create an API key, right? The API key essentially is the API key, the user ID, the user email. It's base64 encoded, but I want to show you the plan. The plan is something, so when you define with the developer portal, where you can do different plans, and each plan can have a certain QF. So essentially, in this case, I'm going to define a certain rate limit that I'm going to show you later on, right? That essentially here I define to see a gold plan. So we're going to define these plans, and behind the scene, every time I use that API key, I'm going to be attached to the gold plan, which is going to have probably a higher rate limit than the silver plan or the bronze plan. So I've already applied this. So now if I try to access my book info, obviously I get access to the book info again. So let's now set the rate limit config that will be applied and attached to that plan. So essentially here, I first need to set the rate limit config. I'm going to use the usage plan as a request header. In the X solo plan header name, right? The descriptor key is going to be the user ID, and the path is user ID, obviously the key user ID. So I'm going to then set the rate limit server config, right? And I'm going to say, okay, now take the user ID and usage, the key user ID user plan. And for bronze, apply a 1 request per limit. If it's a silver, 3. If it's a gold, 5. Again, this is very little because it's easier to demonstrate. This shows you that we can implement different plans for your end users on how to access the API. We can also see in the developer portal, you can also attach certain set of APIs to certain users. So certain users get access to certain set of APIs and so on. So I've just set the rate server limit. I'm going to apply the policy, essentially bring the server config and the rate limit server config and the rate limit client config and connect them together. I've created that one. And now I need to also create the rate server settings, essentially defining where my rate limit server sits, right? Because here I define where does my rate limit server sit. It's called rate limiter in the GlueMesh add-ons namespace. Cool. If I now run a loop and remember the goal plan access to 5, maximum 5. So I can say here 200, 200, 200, 200. And as of number 6, it's 4, 1, 2, 3, 4, 5. Number 6 indeed is 429, just like Krisztian was showing earlier. So that's been successfully applied. So now, obviously, I usually have more than one API, right? So let's stitch them together into an extra into one API called to one route table, essentially. So I'm going to use the openlibrary.org here. Essentially, the use case is our book info page shows information about books. I need to also be able to attach the languages that are available for each book. So I'm going to connect these two together. I'm going to apply this here. Oh yeah, I need to indeed. Here you go. I'm going to attach the route table to it. And essentially what I'm doing, using the same route table, if I go to /bookinfo, API/bookinfo/search, I'm going to rewrite it and actually forward that request to openlibrary.org. I'm going to apply this, and then the other API is still available via the same route table. So if I use this here, I get access and I get the languages that I need. Cool. So let's expose the dev portal backend now. So what I'm going to do, it's very easy. I'm going to here set the full destination, cluster, port rewrite. As I mentioned here, I'm going to forward it to the portal server. So I got a backend portal server, and essentially I'm saying if I go to /portal server/v1, forward it to my portal server, right? Here you go. I'm going to have this applied. And if I go to the, if I call this, oh, come on, my mouse is not moving. Here you go. And if I call this, portal config not found, because you need to define the portal config first, which is what we're going to do now. Right? I pointed to my portal server, but the portal config hasn't been applied yet. So here's where I can also apply these plans, right? A bronze plan, a basic plans, etc., based on the same plans and tokens. And a plan can be attached to a set of APIs, can be attached to the rate limit config, and so on. So I've just created this. And if I go this here, I see there's nothing attached to it because I still have to assign the APIs that are accessible for that user into a portal group. So with the portal group, I'm going to define with certain users, access levels here, portal users, claims group users, access levels, users plan gold gets access to all my APIs that have that label set. Awesome. If I now run that same command again, this is doing later. I should later on, when I actually expose that, I will have access to the APIs. Cool. So we're going to install the portal server. We provide that as a template on how to view it's highly configurable. I'm going to publish that Docker file here. Essentially, this is a very new feature. Obviously, it's going to be included soon. But in this case, what I'm doing, I'm cloning the original portal server, right? And I'm pushing this to Docker. So this takes a couple of minutes. Let me, in the meantime, walk you through what we're going to do next. So I'm going to deploy obviously the application. I'm going to deploy the Docker image. I'm going to tell how to expose that Docker image. And then next I'm going to expose the portal frontend through the ingress gateway through using a route table. So essentially I'm saying if I go to portal, prefix /portal server /login, portal frontend, I get access, I get forwarded to the portal frontend essentially. And what we're going to see next is access to the portal. So I'm going to wait 1 or 2 minutes for this to be done. If you click on API, because we don't have defined any public APIs, this is where I'm going to define what my public APIs are. And here you go. I'm going to define my OIDC config here, my external authentication policies, external authentication server. And once I get access to it, I'll have access to my REST API because I need to authenticate before I can actually see the APIs that's sitting behind it. So I'm going to wait for this to finish, and we're going to apply all this one by one. This takes 1 or 2 minutes. We should probably do that as a pre-setting for the demo. We're slightly over time. I think we're going to be 5 minutes over time, roughly. But that's fine. Cool. Okay, I hope this is done soon. Cool. This is okay, we're done. Awesome. So now that we have applied this, let's deploy the portal frontend. Awesome. Let we deploy the portal frontend. We want to expose this to the gateway. Let's have a look if everything has been deployed properly. Okay. So ingress, the portal frontend is pending. So this is not working. Cool. So let me just continue it. Something is the demo guards are not with me today. Somehow we need to double check this before Monday, but let me just walk you through what's going to happen next. So essentially, I'm accessing the web frontend. Once this has been deployed, I'm defining the authentication because, as I mentioned earlier, I need to have a token. I need to have an authentication before I can actually see something. And once I'm authenticated, I'm going to see my APIs. Right. And as I mentioned, one of the cool thing about the developer portal here is the fact that we can have users create their own APIs, right? Essentially, what we're going to do, we need to update to remove the Kubernetes secret API key storage block because we're going to automatically generate them using the portal. So once I have that and I log into the portal, I will have the ability to create new keys and attach them to the goal plan in this case, because that's the only one I've enabled into the portal at this stage, right? So I can generate a key. This could automatically generate a key behind the scenes. And I can then, I need to update the API key user one into Keycloak. And then once that is done, I can obviously access the API using a certain API key. So now let's talk about monetization for a second. So we mentioned usage plans, right? And you may want to, you need to measure how many calls are sent by each user, right? But you don't need to measure that. But if you require fine monetization, we can deliver that using the platform. Essentially, what we do here is you need to create a transformation policy to identify all API calls to define the API they represent. Then we create an envoy filter that essentially checks the API call. And then once I have that, I'll be able to check the amount of API calls and get the metrics of very specific API calls that are being made, right? Imagine you want to check all calls that are done with the user plan gold. In this case, I'm calling the endpoint, and I will have information about what the actual user plan is that's being used to access a certain API. This is very useful if you want to monitor the usage of your API calls, essentially. Cool. Sadly enough, there is a small issue with these things. Krisztian will have to look at it before Monday. But I hope you all enjoyed the session, and we are 5 minutes over time.